Okay. We are going to begin today in a very important stretch. Okay. We, over the next couple weeks, are going to discuss different tests to determine if our series converge or not. Okay. What is the difference between a sequence and a series? Matthew? Okay. A series is the summation of a sequence. Okay?
Sigma.
Appreciate that real quick before I move on.
What is that? Sum.
Sum.
I ate some. I.
Okay. So okay. Pi Day is coming up. It's on the Saturday of spring break. Okay. A series is a sum of a sequence. Okay? In this case, we have an infinite sum. So we would call this our infinite series. In this case, where we stop at n, we would call that a partial sum. I also have to be very careful.
Was it partial and infinite?
Mm-hmm. If I cover up the first line, are we good?
Yeah.
Okay.
The only difference, a partial has a definite ending point.
Mm-hmm. Yep. So if I ask you for the fifth partial sum, you sum up the first 5 terms. That is doable. You can even do like the first 200 terms by using your calculator.
How do you know?
However, when we are doing an infinite sum, you can't just punch that into your calculator. All right, so we have ways to determine where and what this converges to. Okay. So we are going to talk about 3 tests today. We are going to add 2 more tests on Thursday and then have a quiz and make sure we're under control. Okay.
Wait, I thought we had this class on Wednesday.
No,
Nope.
we have it on Thursday. Because it's easier. Because we have English
It's
on
odd
Thursday.
Okay.
even.
All right, so here is one test that we're going to talk about. But in general, if the sequence of partial sums of a series converges, then we say the series converges. So what you probably want to write down is that second thing right there. If we can find the limit of s sub n as n goes to infinity, then we know that that infinite sum is going to converge to that. I would just write that second line.
Who's the number?
Everybody just got a message from the school saying that a sensor on the sprinkler system was triggered and the fire department reset that alarm. So
How?
we're good.
That's it.
That's all we know.
You know, like throw a pencil on it and trigger it?
I don't know. Okay. So this is the example that I'm going to show you, and we actually have a name to this, but I'm not going to give you the name until after we do the problem. So please write this down. This is a very important one. Okay. If we can determine what the partial sum would be, like what the nth sum is, we can take the limit towards infinity and figure out what it converges to. Okay, some of us may be seeing a pattern. Let's just talk about the nth partial sum, so we can use that limit that we had on that previous slide.
Sure.
What's our first term?
1.
Minus 1/2,
Yeah.
right? Our second term,
1/2 minus 1/3.
our third term.
1/3 minus 1/4.
Okay. Our fourth term.
1/4 minus 1/5.
Okay, is that enough?
1/5 minus 1/6.
All the way until 1 over n minus 1 over n plus 1. Happens. Those cancel.
Whoa. Us is 1.
Those cancel. No. These cancel. And that pattern's going to continue.
Until the end. Until n. Oh, 1 minus 1 over n plus 1.
Okay.
I get it.
So our nth partial sum is 1 minus 1 over n plus 1. This is what we call a telescoping series. Can you see why it would be called a telescoping series?
No.
But like, if it goes on for infinity, then 1 over n plus 1 is last.
Hold on. So now we're going to take the limit as n approaches infinity of that partial sum.
1 minus 0. 1.
So this series converges to 1 because it is a telescoping series.
That means the sum of it is 1.
Yes. Now, it is not, with these tests, there are very few that we can find the actual sum. This is one of them. And we can actually find the sum.
Why is
Now-
it called telescoping?
Because of the pattern that cancels out. Wiggle it down.
Okay.
This has to be set up perfect in order for this to work. Okay? In order to have in order to be able to use the limit of the nth partial sum, you have to have these canceling out. That's only going to happen every so often when your subtraction is set up perfectly. Okay?
So it's going to show up one time.
It'll show up maybe a couple times, but it's not going to show up very often. So we need to have other ways to determine if our series converge or not. All right? So let's talk about a series that you have actually proved can converge. Back in Algebra 2 and in pre-calculus, you talked about a specific kind of infinite series. What? Geometric. So here is test number 2. An infinite geometric series we can find the sum for.
Is there a reason the infinity's on the side, not on top?
It was just the formatting of whatever I was using to get that up there.
It's the same thing.
It means the same thing, yeah. One thing about being a math teacher is not all math type is created equal.
Yeah.
I need to go back and fix it, but we can be flexible. Okay.
Is A like the initial value? Yeah, let's say.
So this will converge to a specific value only if the absolute value of our common ratio is between 0 and 1.
What?
So this is what we call our common ratio. In our sequence, like, let's see, 3, 9, 27,
Oh, I got it.
81.
So if
Two.
R is greater than 1, it doesn't converge.
Nope.
Diverges.
Mhm.
243.
Thank you. But if R is less than 1, okay, let me give you an example. there is a certain number of space between me and the door. I'm going to cut my distance in half between me and the door with every step. So I'm going to half my distance. I'm going to half my distance. I'm going to half my distance. Am I ever really going to make it to the door,
No.
theoretically?
No.
But am I pretty much going to be at the door?
No.
Yeah, but what if you doubled your space away from the door? Wouldn't that also do the same thing?
Could you measure the amount of space I just covered getting to the door? You could. But if I doubled my space, I'd get further and further away. And if you add up all of that, it's just going to go to infinity. Do you see what I mean? If the absolute value of r is less than 1, we can actually add up the infinite distance, okay? Now, this is going to converge. So first of all, you say if it converges or not based on this right here. Additionally, we actually know what the sum is going to be. It's going to be a over 1 minus r. I think we're going to get... What?
What is that? A over 1 minus r. That's what it converges to?
That's what the sum converges to. Okay? I am going to make a note that A is the quote-unquote first term. Meaning, whatever this number is right here, when you plug it in, that's the first term of the series. Okay? So if this is n equals 2, you're plugging 2 in for n, and that's what goes here. It's the first term, but not necessarily the first term. Are you with me?
I'm confused on what A and R are in that.
R is our common ratio. It's being raised to a power. And that's how we tell something is geometric. R is being raised to the n power. So R is a number.
It's a number.
Yeah, it might be like 1/2 to the n power, maybe 2/3 to the n power. A is also a constant.
So is that A different from that A?
Sometimes. When your geometric series looks like this, then yes, these A's are the same.
Because it starts at 0.
Mm-hmm. But if this were to change, then we need to be a little careful. And we're going to work on that Thursday. Okay? So here we go. Here is a summation. Please write it down the way that you see it. What is happening from term to term to term?
It's getting smaller.
It's getting multiplied by 2/5.
Okay, we are multiplying by 2/5. So we could say that this is the sum from n equals 0 to infinity of 3 times, you said 2/5? 2/5 to the n. Why did I write it like this? 3 is our first term. And 2/5 is what we continue to multiply from term to term to term. Okay, are you with me?
So, yesterday we didn't plug in 1 or 0 ever. But today we do.
Sometimes for geometric sequences, they will begin at n equals 0. That's kind of like the one exception. Sometimes you will see them written like this. These mean the same thing, okay? But you are right. Yesterday I said n equals 1. Geometric is like the only time we make an exception to that rule. Okay. Now, does this converge? Yes or no?
Yes.
Yeah.
Okay. We know that this converges because it's geometric, where the absolute value of r is between 0 and 1. What?
Converge at 5?
Additionally, we can determine what it converges to. Okay? We know that it's going to converge to 3 over 1 minus 2/5. Which, yes, is 5. But what you're going to have to get used to telling me is if it converges or diverges and what your reasoning is. So we know that it's geometric where the absolute value of r is between 0 and 1, which is why we can say that it converges. If I were to give you something like this, can you see that it's geometric?
Yeah.
Because we have a constant raised to the nth power.
Yeah, that doesn't.
Okay. It doesn't converge, so we say that it diverges because it's a geometric series where the absolute value of r is greater than or equal to 1. That is what you would put on your quiz on Monday. Okay. All right. Last but not least, this is actually the most important of them all because this can save you a lot of time.
Yeah.
Nth term test for convergence.
Okay, the nth term test says that if a series, I don't ignore this comma. If a series converges, then the limit as n approaches infinity of a sub n equals 0. That is not helpful. Flashback to geometry. It's been a while for a few times. This really isn't that helpful. The contrapositive is what you are going to like bold and underline and make a big star and circle. Does anybody remember how to do the contrapositive? Okay. If not B, so if not B, if the limit as n approaches infinity of our sequence is not 0, then not A. Then our series diverges. And this right here is what we are going to use as the nth term test to determine if a series diverges. If the limit of our sequence is not 0, stop. It diverges because of the nth term test. Mrs. Homan, what if the limit is 0? Then we know nothing.
I thought
Like
limit to
makes it so
infinity
that we
was like
don't have to do extra work trying to figure it out.
So this just is going to tell you if it diverges or not right
What's
away.
A to the n? Exactly.
What?
What's A to the n? Exactly.
The sequence.
Like
So
the whole thing.
Is this for geometric sequences?
This is for all.
All of them?
any series. Any series. If the sequence limit is 0, stop. It diverges. Okay? Now, if our limit is 0, then we just have to pick a different test to use based on what it looks like. Okay? So, for example, over here, if we take this sequence right here, the limit is 0. That tells us nothing. But we could use the geometric test to tell us that it converges. Okay.
So the limit's 0 because it just gets smaller.
Yeah, 2 to the 5th.
It just gets smaller the higher the.
Yeah, this goes to 0 because it's yes.
So if the limit equals 0, then will it always converge?
No.
Oh my gosh.
And that's why we have like all of our other tests. Okay?
I figured you were going to say that.
Oh.
Since you loved your homework so much, this is our first example.
I think you're mistaken the word wrong.
Like, technically, couldn't you just treat, like, n factorial as, like, x? If you're trying to, like, cancel things out.
Is it factorial or factorial?
Factorial.
I say factorial.
Is there an I?
I thought it was IAL, no.
I'm
It's
gonna
like
look it up.
like
Doesn't
different
matter.
doesn't
Like
matter.
anyone
I
who
think
hears
it
you say
matters.
that's gonna know what you're talking
It
about.
really does.
Do we have this written down?
Yeah.
Okay.
Yeah, we're good here.
You should always begin by determining what the limit of your sequence is. In this case, think about the limit as n approaches infinity of n factorial over 3n factorial plus 2. Mrs. Holman, how do we do a limit with factorials? What's true about the degree of the numerator and the denominator? They are the same, which means, what is the limit? 1/3. Wait a minute, does that equal 0?
I gotta say no.
Since
It is factorial.
Factorial.
Since our limit does
What
not
accent
equal
does this
0,
have?
then this series diverges because of the nth term test. You have to write that.
Did you say diverged and then nth term right next to it?
Yeah.
Full sentences are half.
Yeah, it doesn't have to be a full sentence. I just need to know if it converges or diverges and how you know that. Okay.
No, guys, I think we're doing good. Someone probably thinks otherwise, but I think we're doing good. I'm proud of us. That I gotta say that diverges.
Yeah. No. Yeah, wait.
You can do that. Just
No,
with
that's
the gym.
definitely converges.
What does it converge to? How do you know that it
Wouldn't it go to
converges?
No.
0?
Our
It goes to
that's
infinity.
geometric. It
Oh.
diverges.
Okay, we do the
That's
geometric test.
We can do either one.
Just go-
Okay. You can use the nth term test and say that the limit of 3 to the n is infinity, which is not 0, therefore it diverges by the nth term test. Zane, you could also say that the absolute value of r is greater than or equal to 1, so this diverges by the geometric test.
Not to say, guys, we're doing good here.
You could use either one in this case.
This is like, I feel like I'm in geometry again.
Geometry was
We had to like give you a reason for your time.
Geometry was so long ago.
I didn't like geometry.
It describes
That was my least favorite math class.
I like it.
This is our last example, which is kind of going to be anticlimactic, but you'll see why.
Goes to 0.
Okay, so Richard is saying that the limit as n approaches infinity of our sequence is 0.
Yeah.
Which means we know nothing.
That's what I'm talking about. That's what I'm here for.
Okay.
No, nothing.
Cool.
That's it.
We know that the limit is 0. Now, this is not geometric,
Yeah.
so we can't use any of that rule. And this is not telescoping because we're not going to have,
I mean, minus.
you know, we don't have a subtraction of 2 items that things would cancel. So we're gonna have to wait
Tomorrow.
until tomorrow
Yeah.
Nice.
That's what I like to
in
hear.
order for us to know
And it diverted.
that it diverges.
IDK.
One
Still does.
plus
Just
one
end
half.
our lesson
Plus one
with
half.
that.
Plus one half. Plus
I
one
like that.
Plus one half.
End every lesson with a Dragon Ball. Dragon Ball.
Okay, now I say tomorrow because for us this year in
Oh, it's
2020,
Thursday.
it's gonna be Thursday because of block scheduling.
Change it.
It's okay. They already heard us. They know.